welcome back. My name is Colin Howard. I'm a Maximo technical specialist here at IBM, and today we're going to be covering Maximo work order intelligence. So one of the biggest challenges that I get from clients is around the quality of data that they're collecting out in the field. Several challenges that clients have mentioned to me is, for example, technicians completing the work. Just as they're completing the work, they are just clicking whatever comes first down in the drop down within Maximo, or in the case that it's a supervisor. Another example is as they're creating work to be scheduled, oftentimes leaving out the problem code. The reason why this is important is because when you look at reporting across locations, sites, and you want to understand where you're realizing the most failures, what is the most critical problems you're seeing across your critical assets. Not filling out this information causes a lot of challenges. Not to mention our predictive models within Maximo really are really require that level of information when processing and looking at, okay, we can predict a model within X amount of days that this asset is going to fail. So problem codes, failure codes are extremely important when doing recording when creating work. So that's the one of the challenges we're addressing today. So for this demonstration, I'm going to walk you through how a maintenance manager can use AI to recommend a problem code so that instead of having to sift through a variety of different problem codes, they can just get a recommendation using AI, click into it, and complete the rest of the work. So, as I mentioned, for this demonstration, we're going to walk you through a common scenario. Let's say for this scenario, there's a problem with a combustion engine that is identified and reported by the operator through the creation of a work order, through the work order application. That'll be step one. Step two, we'll have a maintenance manager review the work order that was created, and we'll either accept or review the AI recommendation problem code. So let's get to it. So the first step in this process is to go ahead and create the work order. As an operator, I would then just click the Create Work Order button in the top right-hand corner. Enter a description. Let's say that the engine vibration, there's noise and a smell of gas. Now, as I'm entering all this information as an operator, the AI can take many different parameters, including the description and other fields that we're collecting in this work order to process and give the maintenance manager a recommendation when they review the work order. So here I'm just going to say that this is corrective maintenance, that the asset is that gas engine. We can scroll down further to specify maybe a failure class. And lastly, we're going to leave a problem code blank, but it's important to note that within Maximo, this is one of the challenges maintenance manager realize in their day-to-day is all the different problem codes that we could potentially be tracking within Maximo. And here you can see there's over 400 problem codes currently in Maximo today. So as an operator, we're just going to go ahead and fill out some of the information for this work order and just click the Create button. So now that work order 1208 is created, we're going to shift roles over to how a maintenance manager would then review the work order and associate a problem code using AI. So as a maintenance manager, very similar to what we saw with operator, I'm going to go ahead and open up Maximo, go to our work orders, and here you can see we can begin filtering based off of a number of different filters, including description, location, asset status, and the type of work. We can also, for this example, maybe we get notified that there's a specific work order that needs our attention. That's from the operator. He created that, or she created that 1208 work order. Let me click into that. Now, one thing to point out here as well is I set this up to have the AI model run in the background every minute. Let's go ahead and scroll down and see that indeed the AI model was able to run. And so I'm going to talk a little bit about this. Um, and here we can see that there is a recommended vibration problem code that the AI has picked up with 91% accuracy based off of the information the operator gave in the description and in the work order. Let's go ahead and as a maintenance manager, I'm going to want to go ahead and review the work order that's been created. As we scroll down to the problem code here, I can just click the recommendations to review what recommendations the AI has presented us. Here we have three recommendations: vibration, parameter deviation, and if this is a plugged or a plugged problem that we're having. And over on the right-hand side, you can see the level of confidence that the AI had and that this is indeed the associated problem code. Now, the more work orders that you feed the model that has an associated problem, the more intelligent this model gets. And so here, based off of the information that we've given it, it has a 91% accuracy that this is indeed the problem code it recommends. Again, this is meant to augment the maintenance manager's knowledge. So maintenance manager may still choose not to go with the recommendation, but that's a feedback that he can give, and I'll show you a little bit later, give to the AI so that it trains properly. So let's say for this example, let's just go ahead and show you what would happen if we were to change, for example, the description of this work order to, let's say, blocked air filter, which this description would be associated very clearly with a very different problem code. So if we save the record and try rerunning the model again, let's see what recommendations it gives us. There you go. After the changing the description, we are presented a completely new problem code with a different level of confidence, in which, as a maintenance manager, we can choose to click in and save the work order. The next thing that I want to highlight as part of this demonstration is how do we actually train the model itself? So what we do is we choose a specific group of work orders we want to train the model with. And for this model that we created, we trained it using just a small subset of work orders for this demo. As you can see here, here's all the work orders, 112 work orders that we trained across all of the problem codes associated with this this type of equipment. And one thing that's important to highlight is these are all completed work orders that have an associated problem code that we trained the model with. Now, now that we know what we've trained the model on, the last thing I want to show you is within Maximo, where does this actually exist? So we'll migrate over to the AI config application within Maximo, where we can see the AI model that we've trained. And we can also, just as importantly, look at the model status. With a small set of data, we train this model to have 80% accuracy. The model accuracy score is between 0 and 1. So this is just a quick example of how Maximo can leverage generative AI to help assist maintenance managers when improving the level of quality within level of quality of data within their work orders and help them track problem codes. So not only will this help to improve reporting, but this also can help drive better reliability strategies as well as drive predictive maintenance that can be created in the future. So thank you for your time, everyone. This is just a quick demonstration of generative AI, and I look forward to more demonstrations in the future.